Hello students. Now we'll discuss the centrifugal casting. What do you understand by centrifugal casting? As you can see in the diagram, the centrifugal casting basically consists of two sections. The number one section consists of the mold, and the number two section is the pouring basin. So in the centrifugal casting, uh, basically what we do is we use the centrifugal force. So the equation for the centrifugal force is mv square by r. So r is the internal radius, and v is the velocity of the flow, m is the mass. Now this is the equation that is representing the centrifugal force. Now this is particularly useful for producing the cylinders or rotational symmetry components. Now very important equation is to find out the speed. How much is the speed? So the speed, it basically depends upon a certain parameters, that is the gravitational factor and the inner diameter of the mold. ना जैसे कि आप देख सकते हैं कि सेंट्रीफ्यूगल कास्टिंग क्या है. सेंट्रीफ्यूगल कास्टिंग में दो प्रोसेसेस हैं, पहला प्रोसेस और दूसरा प्रोसेस. पहले प्रोसेस में क्या हो रहा है, हमारा मोल्ड सेक्शन है, दूसरे प्रोसेस में हमारा पोरिंग सेक्शन है. रोटेटिंग सेक्शन रोटेट करेगा, जिससे सेंट्रीफ्यूगल फोर्सेस से इसमें ट्यूबुलर टाइप के कंपोनेंट्स जो हैं वो बनेंगे. तो ये हमारा सिलेंड्रिकल कंपोनेंट्स हो गया, ट्यूबुलर कंपोनेंट्स हो गया. इन टाइप के कंपोनेंट्स को सेंट्रीफ्यूगल कास्टिंग बनाती है. नेक्स्ट वी कैन सी इज द सेमी सेंट्रीफ्यूगल कास्टिंग. In semi-centrifugal casting, what we have is we have the rotating table. So beneath is a table and it is rotating, and above is the cope and the drag, and following the flasks, the pouring basin. Now what is the rotating table? The rotating table is the mold is mounted on the rotating table, which rotates the mold. Now we have the flask. It supports and holds the molting material in position during the casting process. Now the pouring basin is the molten metal pouring through the pouring basin into the rotating mold cavity. Then you have what the centrifugal action. Due to the rotating, the metal forces outwards against the mold walls, so filling the mold cavity. Then the casting is being done. As the mold rotates, the molten metal solidifies to form the required component. Now this is centrifugal casting. In centrifugal casting, we have the center gating system. Similarly, the runner, the rotating table, centrifugal forcing, and the casting. So it's almost similar, but what is the difference is there are some parts that needs to be filled, or there are some portions that require the cavity. So this type of centrifuge casting solves that purpose. Now we have the cupola furnace. Now what is the cupola furnace? A cupola is basically used for melting the cast iron in the foundries, and its construction, it is a vertical cylinder that is lined with refractory materials and has a charging opening at the top. Now the fuel used here is the coke, that is commonly used as a fuel, whereas limestone is added as a flux to help the remove impurities. What is the working principle? Air is supplied at the bottom, and the burning coke produces heat, which melts the metal into this uh, section. So basically we can divide this cupola furnace into number of sections: the bottom section, the mid section, and the top section. Now the bottom section is supported by the pillars. Then it has the, you can say, the sand at the bottom. Then you have the slag spout, that is the passage through which you can collect the slag. And then this is a blower from which air has been blown, and this is a charge. And when the process heats up and the metal is removed, so this is the portion where the metal is ready to be tapped. So this is a cupola furnace. Then there are three types of crucibles. One is lift out crucible, then stationary pot, and the tilting pot furnace. Now first is your crucible with a lift out crucible. So here what you can see is uh, in the crucible what you do is you basically uh, heat with the fuel, then so the stationary pot, you can see how the stationary pot is there. So this is a lift out pot, you can lift it. So once removing the cover, this pot can be lifted. This is a stationary, it won't be lifted. It is mounted with respect to the wall, and the metal is being poured from the stationary pot. Then this is a tilting pot furnace where we have the arrangement, mechanical arrangement for tilting the liquid outside, and these all components are same, but their mounting and their rotating are different. So this is a crucible furnace explained here. Equipment types, what type of metals can be melted and formed, and how the heating mechanism takes place. What is a refractory lining? So how the high temperature of the refractory attains within the chamber. Then this is the induction furnace. In induction furnace, with the help of the electricity, we are heating up the metal and then taking up the metal. So here what you have to understand here is how in the induction furnace the copper coils are being mounted, how it has been covered, how the refractory material plays its role in maintaining the heat inside the chamber. So this is explained here. The working principle of fundamental working principle passes through generating the current, then how the internal heat is being generated, then if there are some magnetic stirring actions when required, then what is the type of channels or structural configurations, and the operating advantage, like it's high energy efficient and very low carbon or gas contaminations, and we can precise the temperature control and minimum oxidation reaction. Then this is the common types of ladles, cradle, and two mantles. So we have the tilting cradle. So what cradle is, it receives the metal from the furnace and allows the convenient pouring into the mold. So this is a channel where the molten metal is conveniently being poured. So there are two common ladles. One is for handling the large volumes of molten metals using an overhead crane, and others are two man-made ladles for manually moving and pouring the smaller amounts. So thank you.